So today we're talking about factoring expressions, but before we get to how to factor an expression, we're just going to talk about how to find the greatest common factor. So we have these steps listed right here. These are going to be the important steps that we will continue to use even when we talk about how to factor expressions. And they state that we're going to set up a long division problem with all the terms underneath and blah, blah, blah. I'm not really going to go through and read through them until we actually set up a problem. So they're asking us to find the greatest common factor of 27 and 54. And we could sit here and list all the numbers that we think go into 27 and 54, but I'm always not sure if I have all of the numbers actually listed. So I'm going to show you pretty much a no-fail way to make sure we do find the greatest common factor. So what it says is set up a long division problem with all terms underneath. So our two terms are 27 and 54. So I'm going to give myself a little space and put 27 and 54, and then set up a long division bar. And then it says look at all the terms and decide if there is a common factor. So is there a number that goes into both 27 and 54? And I look at both of these numbers and I think that they're both divisible by 9. Because both 2 plus 7 is 9, 5 plus 4 is 9. So then I'm going to say 27 divided by 9 is 3, and I write that down above it, and 54 divided by 9 is 6. So then I am going to look again to see if 3 and 6 also can be divided by another common factor, and they can both be divided by 3. So I'm going to use another long division bar, and 3 is the common factor, so I write it to the left. And so 3 divided by 3 is 1, 6 divided by 3 is 2, and looking at 1 and 2, there are no other common factors. So then to find the GCF, all I need to do is multiply the two numbers on the outside, and that will give me the greatest common factor. So my GCF will be 9 times 3, which is 27. We can also use this same method when we have 3 numbers. And we follow the same exact steps. So I'm going to write all 3 numbers underneath the division bar. So I want 45, 105, and 75. I just said 5, 5, and 5, so I know that all 3 of those are divisible by 5. 45 divided by 5 is 9, 105 divided by 5 is 21, and 75 divided by 5 is 15. Just make sure your numbers don't blend together. You can tell the difference between them. Stop and look again to see if there's a number that goes into all 3, a factor. And again, I see that 3 does. So 9 divided by 3 is 3, 21 divided by 3 is 7, 15 divided by 3 is 5. So again, to find the GCF, you're going to take the 2 numbers on the outside. Those are the 2 factors that all these numbers were divisible by, and I'm going to multiply them together to now give me the greatest common factor between them. The next choice, or example, also shows us that even if we have a variable, we can still factor this out. So I'm going to put the 12x and the 40x underneath the division bar. And I see that both of them have an x. So I'm going to go ahead and divide them by x. X divided by x, that cancels it out and equals 1. So really, when I do 12x divided by x, I'm just left with 12. And 40x divided by x will also leave me with just 40. Now I will look at the 12 and the 40, and I will say that both of those numbers appear to be divisible by 4. So 12 divided by 4 is 3. 40 divided by 4 is 10. All that I have left to do now is multiply again the 2 numbers on the outside, and I will get my greatest common factor. So the GCF is going to be 4 times x, which is also 4x. For this last one, they are showing us that we have coefficients and multiple variables in 3 different terms. So I'm still going to write 32mn, 16n, and 12n. And all 3 factors I notice that they're divisible by n. So that will leave me with 32m, 16, and 12. Then I want to look and see if there is a number that will factor that will go into all of those, and I recognize that it is 4. So 32 to m divided by 4 is going to still give me 8m. I can't drop that m. 16 divided by 4 is 4. 12 divided by 4 is 3. So again, my GCF will come from multiplying the two factors on the outside to give me 4n. So now, what they're asking us to do is to factor each of these expressions. And the only difference between these examples and the previous 4 examples is now they're applying an operation in here as well. And when they're asking us to factor the expression, we need to write an equivalent expression to our original statement. So there's going to be one extra step that we have to do. So I still am going to set this up as 3n plus 9. And I'm going to divide both of these by 3, which leaves me with n, and n divided by 3, which will also leave me with 3. You need to put, though, the n plus 3 in parentheses, because that is your term that you have to multiply your common factor to both of those terms to get an expression that's equivalent. So your final answer is not just 3 now. We are not only looking for the GCF, we are looking for another way to write 3n plus 9. And that is the 3, which we'll bring down here, and then our leftover stuff, n plus 3. So your final answer is this right here, which looks very familiar to our first step in 7-1. So for the next one, I got squeezed in there, so let's be careful here. We're doing the x plus 4x. You might need to write a little smaller on your paper. X is the common term in both of those. X divided by x again is not 0, it is 1. 4x divided by x is just going to give me 4. And again, both of those numbers are positive. I'm going to bring that plus sign up. So I'm going to now have x and then 1 plus 4, which could be rewritten as x and then 5. I would prefer, though, to keep it this way so that if I was to check my answer and multiply this back out, I would get my same answer. But that's okay. I'm going to just erase that for a second so that we can see this next one. So I have got 15 and 20x. Both terms do not have an x, so I cannot divide both of them by an x, but I can divide both of them by 5. So 15 divided by 5 is 3, and a positive 20x divided by 5 is a positive 4x. Again, you have to include what's on the top now, so we have 5 times 3 plus 4x. And again, if you wanted to check to see if your answer was correct, you can go 5 times 3 is 15, 5 times 4x is 20x. So you can check to see that we get the same answer back. And that's your final answer. For the next one, we have a subtraction sign. This is the first time that's happened, but we're going to treat this very similar. Both of these terms are divisible by 4. So 4x divided by 4 will give me x. Negative 8 divided by 4 gives me negative 2. So again, my final answer will be the greatest common factor of both of those terms, which was 4, and then the leftover of each of the factors. So on the back page here, they're showing us that we're the opposite operations, that expanding and factoring are opposite operations. Sorry for the weird pause. I just had to start again. It says that opposite operations, we have addition and subtraction, multiplication and division are opposite operations, and they are stating here that expanding and factoring would also be considered opposite operations. It is similar, again, to the relationship between multiplying and dividing. So we learned the other day that expanding means that you're going to rewrite using the distributive property, and so 5 times 2x plus 9 ends up equaling 10x plus 45. Now, if we were to take the 10x plus 45 and to rewrite it as a product, it would technically be the 5 times 2x plus 9. It would give us that right back again. Okay? So for examples, the following examples, they're very similar here to what we practiced, and they've kind of already set them up for us. They're saying that 8a plus 4, they'd like us to complete the factor form of each of those expressions. So on the side, if I had 8a plus 4, they're already showing me right here that 4 is my greatest common factor. So 8a divided by 4 would be 2a, and 4 divided by 4 would be positive 1. You must put a 1 there because if you would go back and rewrite here now, write 2a plus 1, if I was to now check to make sure I did this right, when I do 4 times 2a, I should get 8a, and when I do 4 times 1, I should get 4. If you don't put that 1 there as a place value, you won't have the correct expression. For the next one, we've got 3 5/10 m minus mn. And when we look at this, we don't have any coefficients or numbers in common, but I do have an m for both of them. So this becomes 3 5/10, and this becomes minus n. So the only thing that is missing here is the m. They are already showing us the 3 5/10 minus n. Then they kind of pull back the reins a little bit, and they're giving us a kind of a clue as to what it's supposed to look like, but we need to be careful here. I've got 14x plus 21, and when I look at this, I see that they don't have any variables in common, but they do have a common factor of 7. So if I divide both of these terms by 7, 14 divided by 7 is 2. We still need to bring the 2x up, and positive 21 divided by 7 is 3. So your answer is 7, and then 2x plus 3. I'm going to let you guys go ahead and try the remaining 2. Okay? So again, with y minus xy, even though I don't have any numbers, coefficients in common, constants, I still have variables. So the constant variable, the similar variable is the y, so I could divide both y divided by y, again equals 1. So you must remember to include that 1 there. And then the next one I have that they're all divisible by 2, and I will get 2, and then in parentheses 6a plus 8b minus 5c. And go ahead and do the last example here. All right, so my final answer was 3, then in parentheses 4x minus 14y minus 1. You need to be very careful that you don't just write the 4x minus 14y. You need to make sure that you also include the common factor of the 3. Otherwise, you won't get an equivalent expression. All right, so thanks for watching. We'll see you guys tomorrow.